Students, we have just seen an important direct formula to find square root of a complex number. Now let us see the application part of this. Let us see how do we use this formula and get the answers easily for the questions which is repeated in your previous JEE exams. So one such question is, so here what we are seeing, it is the application of your formula. So application of the direct formula. So the question is the imaginary part. They are asking you to find the imaginary part of z. Imaginary part of z. What is z now? Z value is 3 plus square root of minus 54 plus root of 3 minus square root of minus 54. So you can see they have given a complex number z, and where z is nothing but square root of two complex number. Now let us first see what is a complex number given under the root. So under the root, what is a complex number we have, children? So it is 3 plus minus 54 can be written as 54 into minus 1. So under the root 54 into under the root minus 1. So now we know how to write it. We write this as 3 plus 54 can be written as 9 into 6, because 9 6 times it's 54. Root 9 is 3, so I will write this as 3 root 6 I. So 54, root 54 is written as 3 root 6 because it is 9 into 6 under the root. 9 outside, when you take it, it becomes 3, and here it is root of minus 1, that is I. So I write it as 3 plus 3 root 6. So they are asking you to find the square root of 3 plus 3 root 6 I. So let us see how do we find. And after we find the square root, we also have to find the square root of 3 minus 3 root 6. You can see we know how to find the square root of 3 plus 3 root 6. We use the first formula. If you notice, what is the condition there? Imaginary part of the complex number should be greater than 0. So we get square root of this, two roots of this, using this formula. So let us substitute to find the square root of this number. So what I'm doing here, I'm trying to find the square root of this number here. So how do I do it? It is the first case where firstly I would try to find mod of z. You can see mod of z for both the numbers are same, both the complex numbers are same. So what is mod of z here? It is root of 9 plus 9 into 6. What is 9 into 6? 54. So I get mod of z as 9 because it's 3 square plus 3 root 6 the whole square. 3 root 6 the whole square is nothing but 54. 54 plus 9. What is the value 54 plus 9, children? We get 54 plus 9 as 63. So I get mod of z as root 63. So I write it as root of 63 plus or minus plus real part of z. What is the real part here, children? Can you notice the real part of this complex number is 3. So I add this 3 whole divided by 2 plus root of 63 minus 3 whole divided by 2. So this is how we get it. So what are the values here? If you look at this root will now be, what is the value? I'll just erase the first part what we had discussed when we discussed the formula of a square root of a complex number. Here I get this as 66 by 2, which is 33. So I get it as root 33 plus or minus outside root 33 plus I into, you have a I missing here, I into root 60. Root 60 by 2 becomes 30. So I'll write root 30. So root 33 plus I into root 30 is what we get. We can simplify the terms. Root 30 can also be written in other ways. It's 15 into root 2. So either we keep it this way or we can simplify this further. So what is your root you got, children? It's basically root 33 plus I into root 30. But what is the root you're going to get for this? Only difference is the minus sign. So I'm not going to solve the entire thing again. I'm just going to simplify this. Now they're asking you the value of z. When you add this, what are you going to get? So I have root 33 plus I into root 30 and root 33 minus I into root 30 with plus or minus for both. So this plus or minus can be taken common for both. So if you're adding this with the root of its conjugate, remember the root of the conjugate has to be simplified only with the sign, right? Only change is the sign here. So here I can write root 33 minus I root 30. So this is the only change, but this is negative, negative of negative, this is going to be positive. So you can cancel minus root 33 and minus root 33. What are you going to get? It is plus or minus 2 root 30 I. So what is the imaginary part of your complex number, children? This is the complex number what you get, whose real part is 0. The imaginary part is nothing but plus or minus 2 root 30. This is the imaginary part of your complex number. If you notice, this is what you get for the imaginary part of your complex number. So this is how we solve a complex number, the root of a complex number, using the direct formula what we have studied. Now let us take another example, one more example, to understand how exactly we solve using the formula. So children, whenever we write a formula on the screen, take a notebook and note down the formula, because it is very important to know the formula, without which you cannot solve a problem. Now let us solve the next problem, which is z. Here also they are asking you to find the value of z, which is square root of 3 plus 2 root minus 54 plus square root of 3 minus 2 root minus 54. So here also we can directly simplify this, children. How do we simplify? I write this complex number as 3 plus, you know what is this? We have just seen what is minus 54. Root of minus 54 will be written as root 54 into I. So root 54 value, we know what is root 54 value. We write it as 9 into 6. It becomes 3 root 6. 3 when it is multiplied with this, it becomes 6. So I'll write 3 plus 6 root 6I. And here it is square root of 3 minus 6 root 6I. So you need to find the value of this. Let us first find the square root of this, and I'm not going to do it separately for the first part and the second part, because they are differing only by the signs. The roots are differing only by the signs in between them. Now let us try to simplify this. How do we simplify this? You know what is modulus of z for this, children? If you are finding modulus of z, just focus here. It's 9 plus 2 into, you know, we have written as 54 into I. So it's basically 2 square is 4, 4 times 54. 4 times 54 is 216. So I will write this as 9 plus 216 whole divided by 2 plus the real part. What is the real part of the complex number here, children? The real part of the complex number here, we are going to get it as 3 plus square root of, here we know now it's 225, so I'll directly write 15 minus 3 whole divided by 2. I simplified this in the next step. So plus or minus square root of, here it's 15 plus 3, that becomes 18 by 2 plus root of 12 by 2. 12 by 2, what is the value we are getting? 15 minus 3, which is 12. 12 by 2 is 6. Here you are getting root 6. So what are your roots, children? It's plus or minus. Here it is 9. 18 by 2 is 9. Root 9 is 3. So we are going to get the value as plus or minus 3 plus root 6I. There is an I missing in each and every formula. Remember, there is an I here whenever you are solving. In the formula there is an I. So it is 3 plus root 6I is the root, that is root of 3 plus 6 root 6I. What is the root of 3 minus 6 root 6I? That is plus or minus 3 minus root 6I. So when you are adding these two, what are they asking you? You are supposed to add these two. You can notice when you are adding these two, plus root 6I and minus root 6I gets cancelled. So in that case, it is plus 3 plus 3 or minus 3 plus minus 3. What are you getting the value as? Either you are getting the value as positive 9, positive 6, or you are getting the value as negative 6. Is that clear, children? This is how we solve for square root of a complex number using the direct formula.